Welcome to the lecture series. In this lecture series, we will discuss about the CNN for Vision-Based Robotic Tasks, that is Convolutional Neural Networks. So, it is Excel for at processing visual data. So, hierarchical feature extraction enables pattern recognitions. Before getting into that, we must know what is Convolutional Neural Network. So, Convolutional Neural Network, which stands for CNN, are foundation deep learning architecture for vision-based robotics, enable robots to interpret visual data for perception and navigation and manipulation. They excel at extracting spatial features like edges, textures, and shapes from the RGB or depth images, mapping them to robot actions such as object detection, grasping, or navigation. So, core applications of CNN in robotics include object detection and manipulation, used for identifying objects in cluttered environments, and navigation and obstacle avoidance. CNN process uh, camera input to identify safe paths and avoid obstacles, and visual surveying, that is control. They provide real-time feedback for controlling robot end effectors, often in eye and hand setups where camera is mounted on the robot. Semantic segmentation and CNN categorize pixels to differentiate between surfaces, obstacles, and target for scene identification. So architecture of CNN is given here. You can find out like we are getting the input, we are going for the feature extraction, and depending upon the polling and algorithm, we are classifying it. So this is the basic structure. And in the typical convolutional neural networks, you can see we have an image. From that feature is mapped, it is pooled, that is it is enhanced, and from that feature mapped to one particular group, and from that again it is pooled and then given to the pattern layer. Now it is fully connected layer given for the classifications, and now it compares to the Donald, Goofy, or Sweetie. So this is the typical convolutional neural networks. So we have to understand the user needs and the robot vision challenge. So environmental visibility, we have to look for environment visibility, real-time processing, resource constraints, and safety and reliability. Problem identification is formulating clear problem statements for CNN-based vision, robot vision. So first one is how we might design CNN architecture that can adapt to the varying light conditions in the industrial robot vision systems. First one. Second one, how might we reduce the computational requirements of CNN for real-time robotic vision on the embedded systems? Third thing, how might we improve CNN robustness for object recognition in cluttered environments? So there are different questions in the implementation. And now coming to the development stage, we have here is architectures like mobile nets, Volo, ResNet, Efficient Net, SegNet, and these individual stands with the different applications like mobile nets. They are lightweight, efficient for the edge devices. Volo, real-time object detection. ResNet, that is residual learning for the complex task. Efficient, it is optimized for accuracy and efficiency. SegNet and semantic segmentation for the scene understanding. So apart from that, we have domain adaptation networks, attention mechanisms, multitask learning, and neural architecture search. So these are the various architectures available for particular and specific applications. Coming to the prototype stage, the flow is nothing but the data collection, pre-processing, model selection, training, and integration. See, we acquire the relevant data sets, normalize it, augment and prepare the data. We choose an approximate CNN architecture, optimize the model for the specific robot task, and deploy that CNN task to the robot platforms. And for that deployment, we use TensorFlow, that is a framework for CNN development, and PyTorch, flexible deep learning framework, OpenCV, computer vision library for the preprocessing, and TensorRT, optimization for the real-time interface. So we have the components like pooling layers. Pooling layers is nothing but reduce dimensions and preserve the features. And output layer is nothing but final prediction and classification layer. Convolution layers, they are nothing but feature extraction and pattern detection. Fully connected layers are nothing but data conversion and classification. Activation layers are nothing but introduce the non-linearity. So apart from these frameworks, we also have the ROS, that is Robot Integration Framework, ML Flow, which is nothing but experiment tracking and model management. Coming to the testing part, what we look for here is accuracy, precision, inference time, that is frames per second, robustness and generalizations. And here you can see, uh, if you want to develop a CNN architecture, we have to focus on the visual data processing, hierarchical feature extraction, core function like object detection, scene understanding, and navigation. Applications include the warehouse automation, robot surgery, and precision agriculture. Here you can see, apart from this, we have few case studies which we discuss in the next upcoming videos, and these case studies will be discussed in detail. Thank you.